In this problem, we are provided with three vectors a, b, and c. So here what we have to do is obtain the value of y, which is present in vector a, which is the y component. The value of y should be such that these three vectors are linearly dependent. Now the quickest way to check whether if given three vectors are linearly dependent or not, all we have to do is take their scalar triple product. So if we take the scalar triple product of a, b, and c, then if they are linearly dependent, then the value will be equals to 0. Now scalar triple product, that's simply taking the 3 by 3 determinant. So in the first row we have components of a vector, so that will be 7, y, 1. Then in the second row we have components of vector b, so that will be 3, 2, 1. And in the third row we have components of vector c, so that will be 5, 3, 1. Then the value should be equals to 0 since they are linearly dependent. Now what we'll do, we will expand this determinant above the first row, so have 7 times, so we have 2 times 1, so that's 2, minus 3 times 1, so that is 3, minus y times, so we have 3 times 1, so that will be 3, minus 5 times 1, so that's 5, plus 1 multiplied 2, so we have 3 times 3, so that is 9, minus 2 times 5, so this is 10, and this value is equals to 0. Now this is a fairly simple equation, and when we solve for y, we will get the value 4. So this is the value of y for which the three vectors are going to be linearly dependent.